Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on transient analysis of RL circuits in S domain. For the following circuit, if switch is opened at t is equal to 0, find I of t for all values of t greater than 0. So initially, switch is in the closed condition and circuit is in steady state. So in steady state, the inductor acts as a short circuit. So this circuit can be redrawn as shown in the diagram. Current sourced by the voltage source is given as I of t is equal to 36 divided by 10 plus 3 in shunt with 6. So we will get I of t is equal to 3 ampere. To find current flow through the inductor, we have to apply current division rule. IL of t is equal to I of t divided by 3 plus 6 into 6. So we will get IL of t is equal to 2 ampere. At t is equal to 0, switch is opened. So here our switch is opened, there is no role for the 36 volt source and 10 ohms resistance. So we can redraw the circuit as shown. So now the circuit is in time domain. Let us transform the circuit from time domain to frequency domain. So here in the circuit, the inductor becomes 0.1 S in series with a voltage source of value minus 0.2 volt. Let us apply KVL in the loop. We will get minus V6 minus V3 minus 0.2 minus VL is equal to 0. Minus 6S minus 3S minus 0.2 minus 0.1 SIS is equal to 0. So we will get minus IS into 0.1 S plus 9 is equal to 0.2, or IS is equal to minus 0.2 divided by 0.1 S plus 9. We can write IS is equal to minus 2 divided by S plus 90. So to find I of t, we have to take the inverse Laplace transform of I of s. So I of t is equal to inverse Laplace transform of I of s is equal to minus 2 e raised to minus 90t u of t. Thanks for watching Circuits Analytica. Enjoy learning.